Hey friends, I'm Scott Hanselman. We're here at Microsoft Virtual Academy, and we are going to talk about Identity Server. We've got Brock Allen from IdentityServer.io. We're going to learn all about this great open source OpenID Connect and OAuth 2.0 framework for .NET, and we'll build an application. We'll do some real authentication today.
Yep.
Thanks for coming.
Yep. Thanks for having me.
All right. So let's take a look at your browser here. You're in IdentityServer.io. This is the homepage for your product, your open source product.
Yep. So yeah, my colleague and I, Dominic, he and I have been working on Identity Server for many years and have had many versions and evolutions over the time. And we are trying to help allow customers to build what's called a security token service. This has to do with doing authentication and web API security within your application sort of ecosystem.
Okay, so like right now when we see Hello World examples, I go file new project, and I just end up having my web API call other web APIs. It's usually no security at all.
Right. Well, yeah, in file new project, yeah, maybe by default there's no security enabled, but that's absolutely something you have to think about, and you have to architect into your application ecosystem. And so, of course, security is a huge topic that's important for everyone to get right. So that's again another thing that we're trying to help with.
Well, and even worse, I've seen people just roll their own security where they'll have just use this HTTP header.
Right.
We'll have keys that we'll put in a table. And then we'll just revoke the keys if there's a problem.
Right, and so I suppose you could roll things like that, but you're building and inventing your own security. We're focused on these protocols called OpenID Connect and OAuth 2. And the idea with these things is that these are protocols that are developed by a large number of people, really smart people who know about attacks and they think about these problems. And then there's a larger group of people who then read the specifications and they try to poke holes in it to find vulnerabilities or whatever. And so you have a lot of eyes on the specs to help make sure that if there's a problem with it, it's going to get it fixed, and we're going to have a solution to that security problem. If you roll your own, no guarantees that you have enough people looking at it.
Cool.
Except maybe the bad guys. So
it makes sense. I should not be rolling my own. Typically, if you're writing an application, unless it's the next great identity server, then you should just use some of the good open source protocols and applications that already exist.
Cool. So can I give you like a little bit of overview of the problem space that we're trying to address here? So this is the IdentityServer.io website, just a bunch of information about Identity Server. We have lots of links here to offerings that we have. One of them is the documentation for Identity Server. And so what I'm going to show you here is sort of the big picture of what we're trying to solve with these protocols, but also specifically with Identity Server. So this is a picture showing the kind of typical kinds of applications that people are building these days. And so what this is trying to show is that we have server-side web applications. We might have JavaScript-based SPA-style applications.
Sure.
We might have native, mobile, or even desktop applications like installed into your desktop operating system. And so these applications want to know who the user is. Okay, that's authentication.
Right.
These apps then, of course, to perform a lot of their functionality, probably are going to be using back-end APIs. And so those APIs also want to know who the user is. So what we're trying to do in our security architecture is identify the user, authenticate them, and then be able to invoke APIs on behalf of that user.
Interesting. In the past, in the last 10 or 20 years, at least in the Windows space, I've seen things like impersonation, where like an entire thread becomes the identity of someone.
Sure.
We saw DCOM 15, 20 years ago trying to call rather than explicitly calling on behalf of, they were trying to pretend to be that person and trying to flow that all the way to the back end. It was very fragile and frustrating.
Sure. And on the other hand, though, it was. I absolutely agree with that. But back in the day, you would get security kind of by free in IIS, checking the little checkbox, integrated Windows authentication to enable what you're talking about. Modern apps and modern deployment scenarios make that harder to use. Imagine you take your web app and running on your web server, and previously it was domain joined, and that checkbox was checked, and so your user coming in, if they're on the domain, they just get authenticated into your app, and you don't have to think too much about it. Take that web server and move it to the cloud. It's not domain joined anymore, and those older security protocols that we relied upon, like Kerberos, can't work in these more modern and more modern deployment scenarios and more modern apps. Same problem with your iOS app, right? Domain join your iOS, your phone. So anyway, those are the problems that we're facing with these modern application architectures.
Okay.
So, so this picture is showing them this kind of high-level idea of what we're trying to build. And again, as you mentioned, every point in here, every network hop is where we want to do some sort of authentication. So every arrow on here needs some sort of security check. So the idea is that when you're calling from the browser to your server-side MVC app, that server-side app needs to know who the user is, and that involves something on the network to prove who the user is. And then same thing, from the web app to the web API, same thing. You need to pass something along the network to prove that identity.
Do each of these things necessarily have to be .NET? These APIs could be in PHP or Python or whatever. What's .NET and what's not?
Right. So the protocols that we're about to describe here are OpenID Connect and OAuth 2 are they were quite anticipated because they were facilitating a lot of interoperability. So the design of these protocols are allowing an interop, a mix of different technology stacks.
Cool.
Okay. So anyway, let me go and talk about the protocols here. So if you want to do security in your app and API, you could use like the templates out of the box for Visual Studio, file new project, and you have your own login page, and you have your own cookies that are being issued by your web app, and you may have accounts and registration code and account linking from a Google login. And the problem is that's fine, but the minute you build a second app and a third app and a fourth app, you're duplicating that code in all three of those locations. So same thing, you don't want to, you want to centralize that kind of thing, especially when you have lots of apps and lots of APIs. So that's, there's a pattern that has evolved over the years, and this has actually been a pattern for a long time now, of taking all that stuff out of your apps, centralizing it, and that's what's called a security token service. Think of this as, especially with microservices being the kind of buzzword these days, the security token service acts as your centralized identity service for all of your applications. So its job is to know who your users are, be able to authenticate them, and then what it's going to do is take that authentication result and convey it over to your apps and APIs.
Okay, so in the pattern of microservices, it's all about single responsibility or minimal responsibility. In this case, it's the STS is itself a microservice.
Yeah, you can think of it that way.
That's job is to do the auth for
Yep, absolutely.
All right, that makes sense.
So the problem here, though, of course, is that the security token service might be running on a totally different domain, right? Maybe it's running in the cloud and your apps are running on-prem or vice versa. So we somehow need to securely across basically the internet convey the outcome of that authentication to your apps and to your APIs. So as the name implies, security token service, it's going to be creating tokens. And the tokens are what we deliver back to the apps to prove the identity of the user. And tokens are what the app then will use to call the API.
And these tokens are significant. They're not just a GUID or a string. They're cryptographically significant, tamper-proof things.
JSON Web Tokens are the typical tokens that we use in these more modern protocols, OpenID Connect and OAuth 2. So yes, so the token contains information about the user, and it's also going to be, as you said, signed. So there's a digital signature, and the signature is being created by the security token service itself. Okay.
So they encapsulate best practices, and I assume that they expire and different whatever you need them to do, they can do.
Sure, absolutely. So there's a whole, like once you set up the basics, then you actually have some more architecture to sort out about things like session lifetime, how often do you expire these access tokens, how often does the user need to go back and re-authenticate. So absolutely, every environment has different requirements. So those are things that you are still going to have to think about and figure out what your approach is going to be.
But that's the benefit of using a more open system like this, that you have the ability to make those customizations and make those decisions.
Yeah, specifically with IdentityServer. So actually, I guess we'll get into that, but that's exactly the idea here is IdentityServer is a framework for allowing you to build your own security token service.
Okay? So it's not, so IdentityServer is more than just a security token service out of the box. It is a toolkit as well for you to build your own that behaves the way you want it to work.
We like to think of it as a framework. And so you pull it in, it's sort of like jQuery or even kind of like MVC. It's a library, you pull it in, and you build around that to solve your requirements.
Yes, that makes sense.
Now there are other security token services out there. Okay, there are paid products that you can buy to solve this problem as well. Some of them are deployed on-prem. Some of them can be deployed to the cloud, a lot of cloud hosted. So Ping Federate is an example of one, a commercial one. It's very popular in the Java space. Some of the cloud hosted ones, obviously Azure Active Directory is a cloud security token service that Microsoft offers. There is a company called Okta that provides one. There's Auth0, and there are a number of others as well. So it's actually quite a saturated space.
So there's security token service as a service.
Yes.
Like someone else hosts it, handles it for you.
Yep.
And then there's ones that you can host yourself, and you have more control over the flow and the experience.
Yes, exactly. So the reason we built IdentityServer, despite this being a saturated market for security token services, is that we found that when we were doing security consulting for our customers, they obviously wanted this centralized identity management. This also gives you single sign-on, and so there are a lot of benefits to it. But the business requirements that our customers had, the token services that they were using, like some of the cloud-hosted ones or the paid products, they weren't flexible enough to allow the customer to actually do things the way they wanted to. Okay, so that's actually why we created IdentityServer, is provide you a framework that does all the hard security stuff according to the specs,
right?
But allow you to do the kind of customization and provide you the flexibility that you need.
Okay. So our goal over the course of the day here of this MVA, we're going to actually host our own security token service on IdentityServer4.
Exactly.
And we're going to then make both a web API and a web app, and they'll communicate with each other via that security token service in a secure way.
And according to the standard as well, so the OpenID Connect and OAuth 2 protocols. So again, one more thing about this, the beauty about the protocols is that, yes, you can stick in IdentityServer, but if it doesn't work for you down the road, we're talking all protocols, so you can swap it and pick something later on if it suits you better down the road. Okay?
Excellent.
But yeah, in terms of what we're doing today, IdentityServer is going to be the token service to use.
All right, cool.
All right.
Is that a good overview?
Yeah, I think that actually that gives us kind of an idea of what we're looking for.
All right, so we understand the problem space and we understand what we're going to try to accomplish today. We're going to take a quick break and we'll be right back and we'll start building and writing some code.